Good morning, everyone. Today, we'll be presenting on the core concepts of computer architecture with a specific focus on system security, protection, and network design. Let's begin. Our discussion today starts with the fundamental concepts of security and protection in an operating system. The primary goal here is to safeguard data, resources, and system functions. Firstly, security is the broader practice of defending against both external and internal threats to maintain three pillars of information security: confidentiality, integrity, and availability, often called a CIA triad. Protection, on the other hand, is more internal. It focuses on managing and restricting access within the system itself, ensuring that each user or process can only use the resources that are explicitly unauthorized to use. There are three concepts from the cornerstone of system security. To implement security, we rely on it. First is authentication, which answers the questions, who are you? This can be done through passwords, security tokens, biometrics, or a combination known as a multi-factor authentication. Once authenticated, authorization takes over to answer, what are you allowed to do? This is managed through mechanisms like access control lists and role-based access control. Finally, encryption is used to protect data confidentially by converting it into an unreadable form using algorithms like AES and RSA. Access control policy. Building on authorization, we have access control policies. These policies have explicitly defined who can access what. A critical principle enforced here is the principle of least privilege, or POLP, which means giving users only the bare minimum access needed to perform their jobs. This approach has several key benefits. It limits damage from a compromised account, prevents accidental misuse, contains malware by restricting its spread, and enforces segregation of duties for sensitive action. Auditing and monitoring. Backup strategies. Security isn't just about prevention, it's also about detection and recovery. Auditing and monitoring involve continuously tracking and analyzing system activity to detect unusual behavior like failed logins or unauthorized file access. This enables quick response and holds users accountability. Backup strategies are our safety net for recovery. After a breach or data loss, a best practice is the 3-2-1 rule. Keep at least 3 copies of your data in 2 different media types, with 1 copy stored offsite. This ensures data can be stored and business operations can continue. Lastly, I will be presenting about solutions and network topology. For a medium-sized company with flaws, a star topology is the most common choice. It is easy to manage, scalable, and a failure of one device does not bring down the entire network. The overall design will be a hierarchical star topology with a central core switch connecting each flaws. Thank you.
Next is network topology visualization. Overall building network architecture. As you can see in the picture, there was internet, firewall, core switch. Each flow we have a switch. Flow 1, flow 2, and flow 3. Firstly, for Flow 1, Administration and Human Resource. Device 1, 5 laptop and 1 printer. We are using a star topology connected to a 8-port or 24-port layer 2 switch. The switch connect to the building core switch. Secondly, Flow 2, Software Development and R&D. Device 2 high spec. Desktop, 2 printer and 1 server. We are using a star topology connected to a powerful 24-port and 48-port managed switch. The server and potentially the developer desktop can be placed on a separate VLAN for security and performance. The switch has an uplink to the core switch. Thirdly, Flow 3, Customer Support and Device 5 Desktop. Topology a simple star. Topology connect to a 8-port or 24-port switch. This flow has the simple requirements. Describe instruction set, machine language, and assembly language. Instruction set is the complete set of machine level command that a CPU can recognize and execute. It's defined how the processor perform operations such as data movement, arithmetic, logic, and control. In simple terms, it's the language the CPU understands, often represented in binary or assembly code. Secondly, machine language. Machine language is a binary program or binary code. Binary code is sequence of instruction and operand in binary that list the exact representation instruction as they appear in computer memory. Thirdly, assembly language. Assembly language is a symbolic representation of a machine language or specific processor. Assembly language is a form that is very dependent on the underlying architecture. That's it for me.
The next one is group of instruction with examples. First one, arithmetic instruction. These instructions perform mathematical operation on data. Example, add adds to value. Adds.p d0 d1 adds the byte in d0 to the byte in d1. d1 equals to d1 plus d0. And the second one, subtraction, one value from another. Sub.l hashtag 10 d2 subtract 10 from the long word 32-bit value in d2. And third one, MULU perform unsigned multiplication. MULU dot W hashtag 4 d5 multiplies the word in d5 by 4 unsigned. DIVU perform unsigned division. DIVU dot W d0 d1 divides the word in d1 by the word in d0 unsigned. And the second one is data transfer or movement. These instructions move or copy data from one location to another. They do not alter the data itself. Examples, move copies data from a source to a destination. Move.b d0 d1 copies a byte from register D0 to register D1. Move.l D2000 copies a long word from register D2 to memory address 1000. And the third one is logical instruction. This instruction perform bitwise logical operation on data. They work on the individual bits of the operands. Examples and perform a bitwise and a bit in the result is 1 only if the corresponding bits in both operands are 1. N.B hashtag 11110000 D0 mask clears the lower 4 bits of D0 or performs a bitwise or a bit in the result is 1 if the corresponding bit in either operand is 1. R.B hashtag 0000111111 D1 sets the lower 4 bits of D1 to 1. EOR exclusive OR perform a bitwise OR. A bit in the results is 1 only if the corresponding bits in the operands are different. EOR.B D0 D1 toggles the bits in D1 where the bits in D0 are 1.
Next is find D1 value after instruction execution. Given D0 000000015 decimal D1 000000055. Number one is move BDO D1, B mean byte, 8 byte is copy the lowest 8 byte of D0 to the lowest 8 byte of D1. D0, 15, lowest byte, 15. The result is D1 000000015. Second is add B hashtag 25 D1. Hashtag 25 is decimal value, 25 in decimal 19 in hex. B operation D1 low byte 15 plus 19 20E 2E. The result D1 is 0000002E. Third is sub B D0 D1. B operation D1 low byte. D1 minus D0 2E. Minus 1519. Result D1 0000019. 4 is Mulu MULU WDO D1. W means word 60 byte. It multiplies the lower 16 byte of D1 by the lower 16 byte of D0. D0 001 21. D1 0019 25. Operation 25 21 525. 525 in hex is 20D. The full 22 byte result in place in D1. The result is D1 0000020D. The 5 if divu w hashtag 0005 D1. W operation, it divide the lower 32 bytes of D1 by 005. D1 000020D. 5 to 5. Operation 5 to 5 105. Reminder 0. 105 in hex 69. The quotient is placed in the lower word of D1 and the remainder in the upper word. The result is D1 6 times. Reminder 000 quotient 00969. This number 6 is ORB0 D1. B operation bitwise OR between the low byte of D1 and the low byte of D0. D1 low byte is 28, 00101000 binary. DO low byte is 50, 00010101 binary. OR operation 00101000 or 00010101 is 00111101 is 3D. The result is D1 000000 3D.
Next, for n.b hashtag S3CD1. B operations bitwise and between the low byte of D1 and 3C16. D1 low byte equals to 69, 16, which is 0101001 in binary, and the result is D1 000002. EOR.B hashtag S25 D1. B operation bitwise exclusive OR between the lower byte D1, which is 25 to 16. And the result will be D1 00000018. Okay, this is the final summary of all the questions. These are all the answers provided. That is all from us today. Thank you.